Hello everyone. In this video, we are going to learn about the opposite of melting a function or melting a data frame. We're going to learn about pivoting a data frame, or another name that this is also known as pivoting table. So basically, sort of going the reverse of melting, or when a data frame is in the melted format, if you wanted to get it as the sort of the tables that you are used to seeing, that's a function to use. So let's see a couple of examples and see how pivot table or pivot function can be helpful for data analytics. As always, we import the modules that we need, and also all of the parts that we did in the previous video that we melted the Billboard data. I've already put them together. Now we have a melted data that we want to pivot back basically based on what we have. So as we saw, when we have a tabular format of data and then we melted it, that's when we used melt function. But if we have a data frame like this, that we have value column identifiers, and then instead of having these value column identifiers, we want them to be represented as columns, then we use pivot. So the inputs for the pivot function, the first one is values. It's basically the name of the value column that you want to be separated across different columns. So this is that value columns. And for our melted data frame, it was rank. And then you have to specify the index. Indexes are basically the identifying columns that you want to be sort of looked at as the primary keys or unique values that represent each row based on the new structure of the data. And we know that in our data, the artist, track, and time were sort of like creating that for our data frame. The artist, track, and time, and not the date, because as you remember, the date we switched it, and we now are associating the date to the rank other than the date to the unique identifier. So that's why we are not including date here. And then columns, we say columns week. This is basically what is going to be the name of these new series of columns, because pandas work in multi-level column names that this shows itself there if we do this. So let's go ahead and give this a try. So we have rank, index, and also column. So now we can see that the columns week have been added here, and then these three identifiers are also here to represent each of these values. So basically we have the same data, but it's really represented in a new data structure here. Pay attention, the pivot table also accepts an aggregate function. So you could think of pivot table as sort of a double purpose group by function. When we were group buying, we were mainly focused on the output or the number or the calculation. But with pivot, if these indexes that you are assuming to create unique data rows lead to multiple columns, then this aggregate function can help you to also do some calculations. So you could basically do the same thing that group by does by the pivot table, and we'll see an example of that. To see the multi-level columns, so let's say PDF here, pdf.columns. Let's see columns, pdf.columns. And this is actually multi-level index. So if we say index, now we have a multi-level index that is based on 3 different columns, and that's quite involved indexes. So to sort of like free ourselves from all of these complexities, you can just go ahead and say reset index. And once you do this, now the 3 identifying columns are added as columns here. So, and also the name week that we specified here now is presented as the name of the index column. Another thing here is, as you paid attention, if you paid attention, there was a difference between pivot table melting function was that we use the df.melt for melting, but here we are saying pd.pivot, or like we are using this function of the pandas over the function of a data frame. So it doesn't matter, both ways is going to work out. So here I'm also showing that I could have just said the data frame mdf.pivot table, and if I do that, I do not need to pass a data frame in the beginning, as I had to in this function. So I had to pass a data frame here. So that's the only difference here, and it's going to result in the same data frame. And also pay attention that I'm also resetting it here, like right after the bat, so that I don't have to deal with that again. So for your challenge, I want you to remember or like work with the air quality data that we looked at in a couple of weeks ago. So if you remember, air quality data did have some identifying columns, and also sort of it was in a melted format. So here I want you to use the pivot table function or the pivot function to have a table that each row represents each day. So the date, this date, and you also have 20 columns that are value of NO measurement for every hour. So pay attention. The first thing probably you will need to do is to only keep the NO measurements. We just want to work with the NO measurements. The other measurement, the other 4, we don't want to have them. But for each column, now we want to have for every hour. So with pivot table, you can actually do this very quickly by just knowing what to put as the input for the pivot table. So give this a try and see if you can do this, as I will show how it's done if you come back and continue watching. So it's very simple. So this is the data frame that I want to work with. As you see, I'm only keeping the NO ones. So I'm passing that as the pivot table. My values are value. I mean, like if you remember if you look at the air quality data, these are the actual value. And the index that I want to keep as that unique identifier is date. And the columns that I want to have them as my name are time. Once I run this, now I have what I was looking for very quickly and very fast. Let's do one thing. In the previous chunk of code, let me make this smaller. We did that by over date, and we know that per each date and each hour there is only one value. Let's say we switch that to day, not date. and there's going to be more than one value or one row based on these indexes. Let's see what will happen. Once we run this, it seems to be working, but when you look at the numbers have a lot of decimal points, while we don't have a lot of decimal points in our original data. So it's probably what's going on is something to do with that aggregate function that we were talking about, I was talking about earlier. So let's go ahead and add this aggregate function here, aggregate function of sum, and see what will change. So once we run this, now the aggregate function of sum gives us larger value. But once we remove this or change this to mean, it will give us the previous aggregate functions or previous result that we were seeing. So we were seeing the same result. Basically, pivot table, if the indexes that you are specifying will lead to more than one row per each identifier, it's going to apply a mean aggregate functions and present that. But if you want something else, you have to specify that. So a caveat when working with pivot table function is, it's not gonna give you an error and it's gonna work. And if you are doing a pivot table and the indexes you're specifying sort of are different, or there are logical errors in the way you want your code to work, it's not going to give you an error, and it's just going to work, and you might be making a major mistake while there is not going to be any error for it. So pay attention to that. The last thing in this video is going to tell you that we could also be doing multi-index pivot tables. So instead of just having one index to become our pivot table, as here, that was day, I could also do date and species and let that do all those calculations for me. And we can see that based on the date, based on the time, the values are presented here, but also now I have based on the date and species, I have a multi-index that shows all of those values for me. And like I said, it's very similar to the group by on the pivot table